Hi everyone, in this video we are going to be learning how to calculate the eccentricity of an ellipse. So we can start off by recalling that the eccentricity is a number that describes how much of an oval an orbit is. High eccentricity, more of an oval or more of an ellipse. Low eccentricity, more of a circle. We recall that the Earth revolves around the Sun in an orbit, and this orbit has a special shape called an ellipse. An ellipse has two center points. Each one of these center points is called a focus. The plural of this word is foci. So in the case of this ellipse shown here, the two foci points, or the focus point, is here and here. The Sun is not in the exact middle of Earth's orbit. So in the case of this ellipse here, this focus point here is the Sun. And we can see that the Sun is really off to the side. It's not exactly in the center of the orbit. So there are two focus points. One of these focus points is the Sun. Before we move on and learn how to calculate the eccentricity, we need to learn the parts of the ellipse. So we should draw this ellipse on our notes. The ellipse, the oval itself, and the two foci, or the two focus points in the center of the ellipse. And then we will label the two foci. Another important part of the ellipse that we need to learn to identify is what's called the major axis. So in this case, the major axis is the line that goes directly through the center of the ellipse, straight through the two foci points. So the major axis starts at the edge of the ellipse, it runs straight through the two foci points, and goes straight through to the other side of the ellipse. Those are the major important parts of the ellipse that we need to know in order to calculate the eccentricity. So before we can learn to calculate the eccentricity, we need to learn the formula. The eccentricity is equal to the distance between the foci divided by the length of the major axis. How do we calculate the eccentricity? First, we will use a ruler to measure the distance between the foci. So remember, the foci points are those two eyeballs, those two dots in the middle. So the distance between the foci would be the distance between them. And in this case, you want to aim to measure exactly in the center of the dot. Step 2, use a ruler to measure the length of the major axis. The major axis is going to be the line that goes from the edge of the ellipse straight through the foci across all the way through to the other edge of the ellipse. And then we would use the formula to calculate the eccentricity. Let's do this step by step. In this case, if we want to measure the distance between the foci, we're going to line up the 0 line of the ruler. Okay, so the first line of the ruler, not the edge of the ruler over here, but you're looking for that 0 mark, the very first solid black line on the ruler, and you want to line that up as close as you can to the middle of the first focus point. And then we're going to measure all the way across until the center of the second focus point, right about here. So in this case, I'm measuring to the nearest tenth of a centimeter. Here's 9 centimeters. Each smaller line represents 1/10. So this would be 9.1, 9.2, 9.3, 9.4, 9.5. And it looks like it measures up to be about 9.6 centimeters. Distance between the foci equals 9.6 centimeters. Next, I need to measure the length of the major axis. Now I'm going to take my ruler and take that first solid black line representing the 0 mark and move it to the very edge of the oval, the farthest edge of the oval. You want to make sure your ruler is running straight through the center of the foci. Okay, that way you know that your ruler is in the middle of the ellipse. We're going to measure all the way across, straight through, to the opposite edge of the ellipse. Straight through to the other edge of the oval, again to the nearest tenth. In this case, here's 14, 14.1, 14.2. It looks like it's about 14.3 centimeters. Length of major axis equals 14.3 centimeters. So if we want to calculate my eccentricity, the formula for eccentricity is equal to the distance between the foci divided by the length of the major axis. First, I'm going to set up my equation. So the eccentricity is equal to distance between the foci, which I found was 9.6 centimeters, divided by the length of the major axis, which I found to be 14.3 centimeters. I set up my equation. Now I can go ahead and do my math to figure out what my answer is. So again, 9.6 divided by 14.3. On my calculator, I get 0.67132. For eccentricity, we want to round to the nearest thousandth. The nearest thousandth is 3 numbers after the decimal. So in this case, I'm going to find the third number after the decimal, which is a 1, and I need to decide if I should round. I look at the number next to it. It's a 3. 3 is less than 5, so I do not need to round. My final eccentricity is 0.671.